Hi Valley Middle Kids, welcome to a math review. Tonight we're going to be jumping right into the target, which is to make sure that you can nail the last 8 targets in the second part of this chapter 1 test. So no trivia question for tonight. First of all, let's take a look at some of the vocabulary words that we're going to be reviewing tonight as we go through the targets. I'm going to have you pause the video and just take and read through those. All right. I know they can be kind of confusing, but I'll explain them as I go. This is a good slide to take and pause it on, though, and quiz yourself on, do you know these things? If you do, you'll do very well on the test. All right. Our first target tonight, then, is 1.8a. I can use the distributive power to rewrite expressions. So go ahead and take and try to rewrite these two expressions using the distributive power. Go ahead and pause the video. Okay. I'm back. Well, the distributive power lets us take and break this into this. In other words, instead of taking 7 times the quantity of 3 plus 2 in parentheses, we can distribute the 7 out, kind of like pass it out and do it here and then do it here. So this means multiply, right? So multiplying 7 by 3 and then adding it to 7 times 2. And that's what I did down here. I just kind of passed it out. I distributed these 7 out. So you can go from one set of parentheses to 2. And sometimes that makes it look easier, or makes it easier to solve. Well, on the other hand, you could take 2 sets of parentheses where we have a group of 10 times 3 minus a group of 10 times 2. And you can rewrite that with one set of parentheses. And you can just take the 10 and multiply it by 3 minus 2. Both ways, you're going to end up with the same result. I think the key thing is, remember, if you're rewriting it and you use one set of parentheses at the beginning, when you rewrite it, you'll have 2. And if you have 2 sets and you rewrite it, you'll have 1. If you have any doubt, solve the problem both ways and make sure you get the same answer. If you do, you've rewritten it correctly. The next target is 8.1b. Rewriting using the commutative power. Think of Mrs. Carruthers commuting back and forth to Valley Middle School. Go ahead and pause the video and try rewriting these two expressions. All right, to commute means to move back and forth. And in this, the commutative power allows us to take and move a number around in the number sentence as long as they're all addition, like in this example, or all multiplication in this example. So if I scroll down just a little bit, you can see that 289 and 11 are compatible numbers. They kind of go together to make an even 300. So I moved that 289 over there so I could do that first. Then I can very quickly go, well, if this is 300, then the total is 336, correct? The same way over here. I took in this number sentence, they are all multiplication, so I can move the numbers around. That's what the commutative power lets me do. So I moved I moved the 4 next to the 25 because I know that 25 times 4 is 100. It allows me to quickly find out that this expression is worth 1700. Okay? Let's move on. 8.1c, 1.8c is the associative power. It allows me to group operations as long as in an expression they're all addition or all multiplication, like in these two examples. I can put those parentheses wherever I want. I don't have to start where they want me to. So in this expression, it's 11 plus 36, and in this one, it's 17 times 4. Go ahead and try rewriting them by moving the parentheses. Okay, I'm back. I know this is the same example I used in the last slide, but it works just fine. You could regroup that and add these two numbers together first, or in this example, multiply these two numbers together first. You notice I did not commute the numbers because just when you're using the associative power, it just allows you to move those parentheses, those brackets. All right, so that's the associative power. It allows you to group numbers as long as it's all addition or all multiplication. If there's a mix of symbols or some other symbol in there, division or subtraction, it does not work. All right, the next example. Or the next target, 1.8d, that's evaluating expressions using the powers. It's important to remember on this portion of the test that you do not need to use the expression. You do not need to rewrite using any of the different properties that we've talked about. This should be evaluate using the properties. sorry. It just gives you the opportunity to do that. All right, so in this one here, as I look at it, we have two expressions here. They're similar to the ones we've done, but a little bit different. Why don't you see if you can evaluate these? Remember, evaluate means figure out. Go ahead. All right, well, in this expression, I see at 15 and 25, I would rather work with those because the 5s are compatible. They add up to a 10, and the 11 and 289. So in this first one here, I took and I commuted. I moved the number over here to make it easier to add this 289 and 11 and 15 and 25. And when I do that, I can very easily see that that's 340. On this other side, I have all multiplication. I don't know what 17 times 4 is, and I don't know what 25 times 17 is. However, I moved the 4 over here because 25 and 4, as I said earlier in the video, are compatible. I know that that's 100. And so I did that first, and I got it 100. And then I took that times 17 because I knew that that would be 1700. And then I multiplied that by 2. So I was able to solve it quickly by using those properties to rewrite it, the associative power, the commutative power. I did not use the distributive power, but here we go. Here's a couple of expressions using the distributive power that you could try using. All right, go ahead and evaluate these and try to use the distributive power. Okay, I'm back. Well, in this one here, I don't know what 5 times 15 is. I know what 5 times 4 is, but I thought, well, what the heck? I can rewrite this as 5 times 15 minus 4, because I know that that's 11. So then now I have 5 times 11, which I can quickly evaluate as 55. Over on the other side, I don't know if I add these two together, I would have to do 8 times 23, and I don't know what that is. However, I do know what 8 times 20 is, and I do know what 8 times 3 is, so I broke it down, I distributed it out, and I was quickly able to evaluate that and find out that that's 184. All right, there's a couple examples there. The next one is 1.10a, domain and range. Go ahead and see if you can identify what the domain of example 1 and 2 are. Go ahead, pause it. All right, now see if you can tell me what the range is for both examples 1 and 2. Well, if you said that over here in the in column, this is the domain, you are correct. So the in, the out, or the x, the in or the x, these are all the domain. The out is the range or the y. So we have in, out, domain, range, x, y. And remember how we talked about those, how we remember it, domain and range, domain and range. Be careful on your test. When I ask you for one of those things, circle the word I'm asking for, draw down, find the range if that's what it is, and circle that. And then draw down and circle wherever your answer is. Make sure that everything matches the range to your range in the answers in the multiple choice test. Okay? All right, moving on. I skipped 10.b and B1 and B2. I want to end with those. Complete the function table here. Why don't you pause the video and see if you can figure out what numbers go in the blanks in table 1, table 2, and table 3. Go ahead. Okay, I'm back. Well, if you take a look at this, we have 50, and looks like it goes to 57 here. So could this be 50? I'm trying to figure this out. I go from 60 to 67, 51 to 58. It does look like it's going to be 50. So if I scroll down, I can find my answer here. It does look like we have a +7 thing going on. So again, you're always trying to figure out what number goes in there, and to do that, you have to really figure out what the equation is, what's the function, what's it doing. So this was a +7, and so I had to subtract 7 from 57 to find the value of that. All right, over here when I look at it, I'm going from 35 to 32. At first glance it looks like it's going down 3. Let me check here, 45 to 42, 70 to 67. Yep, so that's a -3. So here I have 73, so it would have to be 76 over here to complete that table. Okay, and number 3, I'm going to 3 to 21, 5 to 35. It looks like I'm going times 7, so I'm going to put this in. Check a couple other numbers here. 7 times 7 is 49. 4 times 7 is 28. Yeah, so it's definitely times 7, which would mean this would have to be 8. 8 times 7 would be 56. Okay, so we've completed 1.10c, completing the function table, and we've already started to talk about how you have to figure out what the actual, what's going on in that function table to get from the domain to the range or from the x to the y. So now we can get into 10.1b1, a couple of examples there. Why don't you see if you can figure out which is the right equation here for these two function tables. Go ahead and pause it. All right, well, we're going from 3 to 34, 8 to 74. These are pretty big numbers. Let's say that you're totally stumped and you can't figure it out. Well, then you can start going through and looking at the answers. So let's try. We'll pop in 3 into A and see if it works. So if I put 3 in, that'd be 3 times 8, which is 24, and I take away 11. There's no way that that is 34, so I can cross that answer out. B, if I pop the 3 in, it'd be 3 plus 8. That ain't even close to 34, so I can cross that one out. And this one here, if I put the 3 in, 3 times 8, that's 24, not 34, so it can't be this one. Let's try the last one. If I pop the 3 in, 3 times 8 is 24, plus 10 is 34. Let's try it here. If I put the 8 in, 8 times 8 would be 64, plus the 10 would be 74, and so on. So this is our correct answer right here. Working backwards is a good way to solve these. If you can't figure out what's going on within the table, look at the answers, plug in the x values or the input, and see if you can figure out if it works. All right, we'll try it here then too. 6 to 51, again, there's a pretty big spread here, and I don't get it right away, so I'm just going to try the answers. Let's pop 6 in. 6 times 9 is 54, minus 3, that's 51. It looks like that one's correct, but I'm going to go check the rest of them. If I put in here 6 times 9 is 54 plus 2, that'd be too big, that'd be 56. If I pop 6 in to here, 6 times 9 is 54 minus 6. Well, that's not big enough, so that's not it, so I can cross these guys out. And 6 plus 3 here, no way, not even close. All right, so by process of elimination, and solving that problem backwards, I was able to figure that out. So that's a great way of doing it. Over on this side here, these tables here, they were easy enough for me to quickly figure out what was going on in the box, going from the in to the out. But if not, look at the answers and figure it out by process of elimination. Okay, our last target for today is solving word problems. We've already done these problems in class. Why don't you go ahead and pause it and read through them and see if you can figure it out. Okay, well, did you set up an XY table? Hopefully you did. And if you did, you put in a few variables there, and you figured out that you're taking, when you go from X to Y, you're multiplying by 22. So our solution here is Y equals 22X. Remember, draw the table, put in some values, and try to figure out what's going on from 1. I'm sorry, how does 1 get to 22? All right, and our last problem, we'll do the same thing here. Won't you go ahead and pause it, read it, and see if you can solve this problem? Remember, in both of these problems, we're not trying to solve the problem. We're really just trying to write this two-variable equation, so go ahead. All right, well, if you did it right, you would have made the table with the x and the y. You would have popped in 1, 2, and 3, and figured out that you're taking 1 times 164 times to get it there, to 164. So 2 times 164, if I drag this down, 2 times 164 would be 328. And so we find out that y is then equal to 164x. Well, thank you for watching. I hope you have a good evening and good luck on the test on Monday.